Okay folks, Johnny Davo here. Today's experiment is going to be Lasersaber's Jouleringer. Now I've looked at the energetic forum and read the full thread, and Lattice posted this circuit diagram, and it seems to be quite a good one to get started with because he's got a successful replication, and I thought I'd give it a go today. Now I've made one change to the circuit, and this was vital for getting my version working, which is the addition of this 22k pot here. And I've actually misdrawn it. That lead there actually goes to the wiper off the resistor, so it is a fully variable 22k there. Now the transformer I'm using, it's a Fuji transformer, and it's got yellow tape around if people want to identify the one I'm using. And the transistor, it's a 2SD1960, and that's from the camera as well. And that was very important to use that transistor. Now the pinouts are quite unusual. It's ECB looking from the top. So that's the circuit diagram. And up here I've got 2 meters set up. This left one is showing the voltage on a capacitor, and this right one's showing the current draw of the circuit, and that's on the true RMS setting. And I'll just top that up to 16 volts. It's a 16 volt cap, so it can handle that. So you can see that ticking away. That's how fast it's using the energy in the cap. And it's lighting this fluorescent tube. Now this fluorescent tube's just flickering away, and it's not very bright at all, but the fact is it's running, and I'm quite pleased really. I've got the circuit running on such low current draw because it's a good place to start, you know, to actually modify it and try and get, well, increase the light output. But I'm actually had the circuit running for over 3 hours today using a larger cap. But it's quite a good place to move on from. Now I used this cap today. That was a 150,000 microfarad one, and it's not actually that capacity because I've blown it. Half the oil's on the ceiling. I left it connected to a Bedini motor while I answered the phone, and it was a big mistake. But it ran for over 3 hours on that, and I switched it off and it was still going. But you can see the left meter's the cap. It's going to run for a fair time on such a small capacitor. It's a 2216 volt cap, and it's drawing 410 microamps, and that's on the true RMS setting. So the frequency is fairly low on that, so this meter will be accurate. And that's the small little cap, and that's the light flickering away. It's hard to really see it. So there's obviously high voltage going through there to actually energise the gas. But this is the 22k pot, and I can increase the brightness of it by turning the pot, but obviously the runtime is diminished. But the secret is to get this circuit running on 1 milliamp or less, and that's where I have it now. Now the things which I found important to get the circuit running was not so much the coil, because I had success with this little tiny thing here, and also this one, which was just from its iron garden wire, and they both worked. And I found the actual thing necessary to actually get the circuit running was this 22k pot, because anybody who sets this circuit up may find that, I mean, I set it up with a neon bulb originally, and I could get the neon to glow, but the current draw was 200 milliamps, and that's far too high. So basically I had to get the current to the base down, so I put this pot in there, and that brought it down to the 1 milliamp, but I could only get it with this transistor, which is the SD1960 from the Fuji camera. So anybody who's trying this, I suggest you use the actual transistor out of the camera that you dismantle. Now I'll just flick back to that voltage, and I'll turn the pot down again, and you can see it's still flickering away. But if I just let it at the minimum setting on the pot, it will run a fair while. I've not actually timed it, but you can see, you know, the way it's counting down. It'll run a fair while, and it's 570 microamps. And I'll just set it up with a neon bulb and show you that. I just have to disconnect the leads a minute, so I'll just pause it a minute. Okay, that's the flicker flame bulb flickering away. and you can see the energy counting down there in the cap, and the current draw is just under a milliamp there with that. So there's obviously high voltage involved here, and you can actually, if you disconnect the bulb from here when that cap's on 16 volts, this transformer here starts arcing. Now Lasersaber mentioned that, so I think I'm on the right path here with this. And I'll just set up this a large fluorescent tube. It's about a 2-foot one, and see if I can see a bit more light from that. So just bear with me 1 minute. Okay, that's the large fluorescent tube connected up, and that's flickering away. Now, it doesn't look like much, but the fact that it's actually flickering, it's a biggie for me. And the fact that it will run so long. I mean, that's the capacitor counting down there. And bear in mind, it's only at 2,200 microfarads. And the current draw is 910 microamps. So below that magic 1 milliamp. But I've come to the conclusion that the tube is very important in this experiment as well, because I've tried all different types of tubes on this, and they all behave differently. And I think the best ones are going to be like what Lasersaber's using, which is the small spiral. And they seem to be, well, they seem to light the best because it's like a warm yellow kind of light. And these are 250 volt UK jobs. And they seem to be harder to light than those small spirals. So, I mean, these things here, they're quite a lot of gas in there to ignite. But I think the spiral is a small compact bulb, and I think I'll try and get my hands on one of those ones to see how that goes. But you can see that flickering away. And all from a tiny little cap. Where's it gone? There. So that's the cap counting down, and the current draw is 600, well, 200 microamps. I'll just turn that resistor up slightly. It's flickering away. Okay, thanks for watching.